In this video, we're going to be learning how to sketch slope fields. A differential equation includes one or more derivatives of a function. So just an example, an easy example of a differential equation would maybe be like dy dx equals 2x. Right? dy dx clearly represents a derivative, and therefore this is just called a differential equation. Functions that satisfy differential equations are called solutions. A slope field is a way to graphically represent solutions to differential equations. So let's first just review, kind of like going back to Algebra 1 for a minute here. Let's review what lines with different slopes look like. So on this table, we have some slopes listed from -3 all the way up to +3. And we're just going to draw a quick sketch, nothing accurate, just a sketch of what each of these slopes would look like. So let's start over here at m equals -3. Compared to these three negative slopes, -3, -2, -1 that you see on the screen, the one with -3 should be the steepest because that means the slope is really down 3/1. So I'm going to draw a line. We're not worrying about the y-intercept here, by the way. So your y-intercept can be anything. But I'm going to say that that's a slope of -3. Now, of course, without any coordinates here, there's no way to fully verify that. So the other way that we can kind of compare and show our knowledge of what slopes should look like is by comparing them to one another. So for instance, if I'm going to draw the slope of -2, I want to make it slightly less steep. So perhaps it would look something like this. And a slope of -1, again, a little less steep. When we look at a slope of 0, that should be horizontal. Okay, if a slope is 0, again, that means the line is horizontal. All right, now we're going to reverse it. So if we look, I'll zoom in a bit here. Over on the left, we see the slope of -1, the slope of +1. The only difference is that means the rise over run is really up 1/1. So it's going to look something like this. For 2, we want it just a little bit steeper. Okay, if you could make it look like the opposite of -2, great, but definitely we want it to be steeper than the +1. And then +3 is going to be the steepest because, again, that would mean up 3/3. Okay, just to be consistent, I'm going to slide that one through the origin. All right, so that's the idea of what different slopes would look like. Now let's talk about, well, how do we take that and basically turn it into a slope field? So a slope field is a collection of little line segments that are essentially slopes at given points. So number 1 says, given the differential equation dy dx equals x plus 1, fill in the table of values below and then sketch the corresponding slope field. Well, we should be able to quickly fill in the table of values here. That's, again, like going back to Algebra 1. I'm going to plug in each value of x into the equation x plus 1 or the expression x plus 1. And I'm going to just very quickly fill in here that would give me -1, 0, 1, 2, and 3. So what we're going to do at all of the points where x is -2, so that's going to be these 5, we're going to draw a slope of negative. Okay, so at all values where x is -2, we're going to draw a slope of -1. I'm not going to put arrows on it. I'm just going to draw like these little line segments. When the when the x coordinate is -1, we're going to draw slopes of 0. Those should be little horizontal lines. When I have x is 0, I'm going to have a slope of +1. When x is 1, we're going to have a slope, or dy dx is equal to 2. So I want this to be a little bit steeper. I'm actually going to modify this one here. I want it to be a little bit steeper than the last piece, okay, the last 5 slopes we drew. And then the last one should be 3, so that's going to be the steepest. I'm going to make that one the closest to a vertical line. And that would be our completed slope field for number 1. All right, let's take a look at number 2. We're going to do the same thing. Given the differential equation dy dx equals 2x, fill in the table of values below. Okay, so I can quickly fill this in to give me -4, -2, 0, 2, and 4. And now we know that, okay, these at -4 and 4 are going to be the steepest, one going in the negative direction, one going in the positive. We want the -2 to be slightly less steep, and 0, of course, is going to be horizontal. All right, so I'm going to draw a pretty steep negative slope for all of the coordinates where x is -2. And I'm going to reverse it and do the same idea over here where x is +2. Then I'm going to draw a less steep version. So the important part is that when I look at, let's say, these 2 points, I should be able to tell that, for instance, in this case, the slope of -4 is steeper than that of the slope of -2. I should be able to compare them to one another. Okay, so again, there's no way to actually verify if the slope that you draw is 1 or 2 or 3, but we can compare them to one another and make sure your slope of, let's say, 4 looks steeper than your slope of 2. And then I have horizontal line segments in the middle. So you might recognize that if I were to integrate this, that this would give me x squared. X squared is a parabola, right, an upward facing parabola. And you could almost imagine here that if I start to connect some of the dots and the little slopes on my slope field here, and I'll just do it very loosely, I start to get a shape that looks like a parabola and a quadratic function. All right, number 3. 3 should automatically be a little bit trickier because if I look at the differential equation, x and y are both involved. So they're both impacting the slope. So I am going to be multiplying each of these values and filling in the slope. The good thing when I do that is I ended up with, let's see, 5 slopes that are 0. So that's going to make 5 points very easy to plot. And then the others, I'm going to draw slopes of either +1 or -1. So at -1, -1, my slope should be +1. At -1, +1, -1. At 1, -1, we're going to have a negative slope. And at 1, 1, a positive slope. All right, for the last one, you'll notice that the table of values is gone. So at this point, it's really up to you whether you want to create a table of values. If this is the AP exam, they are not going to have a table of values set up for you, but you can certainly take the time to create one if you'd like. So if I make a table of values, I see that both x and y are going to impact the slope here. So I would need 3 columns just like the previous one, x, y, dy, dx. Then I'm going to list all of the points that I have on my slope field that I'm going to need to plot at. And I'm just going to break these into like little sections so we could see it clearer. Then there are 3 points with an x coordinate of 0 at -1, 0, 1. Then 3 points with an x coordinate of +1 at -1, 0, 1. All right, I'm going to go ahead and quickly fill these in here. If you need more time, you can, of course, pause the video to help you fill in dy dx in that column. And now I'm going to plot my slopes. So in this case, we only ended up with one slope of 0, and that's at the origin, so I'll just plot that one in here. So at -1, -1, I have a slope of -3, so I want to make that pretty steep. At -1, 0, a little less steep. And at -1, -1, +1, the slope is -1, so again, a little less steep. So compare those 3 slopes to one another, and we should be able to tell, like, based on the steepness, which one gives us which slope. All right, at 0, -1, the slope is -1. And I'm going to sit here and finish plotting all of these little line segments to complete the slope field. Okay. Hopefully this lesson helped you understand how to sketch a slope field.